Hello everyone, I am Rutuja Shatkar from Volchan Institute of Technology, Sholapur, third year IT department. Today I am going to present a project on microwave oven simulation which I have done in my internship at Emertxe. Contents of this project are: what is microwave oven, requirements, embedded systems, microcontroller and microprocessor, Pixim Lab, CLCD, matrix keypad, ISR, timer, and project implementation. What is microwave oven? Microwave oven is used to heat the food using microwave, which is of form electromagnetic waves. There are several modes in various microwave oven. We are going to implement four modes: micro mode, grill mode, convection mode, and start mode. What is micro mode? This mode is used to cook food in a traditional way. It uses maximum power of 900 watt. In this, the maximum time you set for cooking is 60 minutes. Second is grill mode. This mode is used to cook meat and bread. It works as the micro mode, but its purpose is to cook meat and bread. User can set time as per the cooking time of the meat. Convection mode. In this mode, user can set the oven to preheat for a particular temperature, and it takes 3 minutes to preheat the oven. After preheating is done, then the user can set the time as per the requirements. Requirements of the project are: knowledge in embedded C, MPLAB IDE, XC8 compiler, Pixim Lab, PIC16F877A, 16x4 CLCD, tactile switch, matrix keypad, and timer 2. What is embedded systems? Embedded systems is a combination of any hardware and software which is intended to do a specific task. A general purpose system is used to perform large number of tasks, whereas an embedded system is used to perform a specific task. Types of embedded system: standalone system, real-time system, networked system, mobile system. Standalone system is divided into two parts. First is slave system. This system are not intelligent even though these are embedded systems. Example: semi-automatic washing machine. Second is independent system. These systems can take action by their own. Example: Google car, which is a driverless car. Second is real-time system. These systems are time-bound systems which will take action on a specified time. Failures in this system are not acceptable. Hard real-time, firm real-time, and soft real-time are the types of real-time system. Best example for real-time system is airbag system. Third is networked system. The system which are connected to network. Example: home security system. Fourth is mobile system. The system which are movable are called mobile system. Example: robots. Let's see components of embedded systems. At the middle part we can see a microcontroller which is connected to the flash, temperature sensor at the right side, and power distribution circuit and 6 UF motion sensor at the left side. At the bottom we can see RGB LED. At the top we can see USB is connected to microcontroller, following battery charger, battery, and power supply. How to choose best embedded system? It should have low power consumption, it should be cost efficient, efficient use of processing power, reliability, efficient use of memory. Microcontroller and microprocessor. An integrated circuit which is capable of being programmed to perform a specific task is nothing but microcontroller. It has a design restrictions such as memory size, input-output capabilities, peripheral functions, etc. Choose a microcontroller based on application performance, price, availability of tools, and special capabilities. Microcontroller versus microprocessor. Microcontroller. All components will be in a single chip. less flexible and less design complexity. Microprocessor, all components are assembled separately, it is more flexible and has more design complexity. Let's get into project peripherals. Let's see PIXM Lab architecture. We can see we are using PIC16F877A microcontroller, which is connected to RS-232, LEDs, buzzer, digital keypads, SSDs, matrix keypad, CLCD. These are the main peripherals which we are going to see. There are two types of circuit, sinking circuit and sourcing circuit. Current sourcing circuit, it is that the current is flowing out of the microcontroller towards the ground. In the current sinking circuit, the current is flowing towards the microcontroller. Let's see peripheral of this project, which is CLCD. Character liquid crystal display. In PIXM Lab, there are two types of display, 16x2 display and 16x4 display. In this project, we are going to use 16x4 display. It displays the ASCII character and some special characters. It is most commonly used display. Two types of communication modes are 4-bit mode and 8-bit mode. What is tactile switch? So this is a tactile switch which consists of metal plate and terminal. There are two types of resistor circuit, pull-up resistor circuit and pull-down resistor circuit. Pull-up resistor circuit we are going to use in this project. Tactile switches. Tactile switch is a switch whose operation is perceptible by touch. This switch used to select the mode of operation and to enter the temperature and to enter the time in our project. This switch will produce a bouncing effect when the switch is pressed. Matrix keypad. This is a keypad in which number of tactile switches are connected in a row and column concept. This is used when more number of user interrupts are required and still want to save some controller input-output lines. These keypads are most commonly used in telephones, calculators, digital lockers, etc. Interrupts. An interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the MPU or MCU to stop the processing. Then the MPU or MCU acknowledges the request and attends to the request. Goes back the processing where it was got interrupted. Polling. It is a process where the computer or controlling device waits for an external device to check the readiness or state, often with low-level hardware. Disadvantages of polling. Loss of events may occur during polling, poor response, and less power management. Classification of interrupts. Hardware and software are classified further into maskable and non-maskable. Maskable is classified into external and internal. ISR, Interrupt Service Routine. An interrupt service routine is a software routine that hardware invokes in response to an interrupt. ISR attends to the request of an interrupting source by clearing the interrupt flag and should save register contents that may be affected by the code in the ISR. It must be terminated with the instruction retry. When an interrupts occur, the MPU completes the instruction being executed, then it disables global interrupt enable, places the address from the program counter on the stack, written from interrupt. Timers. Timers is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in a sync with a system clock or an external clock. It has many applications such as measuring time and generating delays, etc. Timer counter is a software designed to count the time intervals between the events. Resolution, which is also called register width, is of 8 or 16 bit. Tick is referred to as the change from one number to another number. It may be up count or down count. Quantum, which depends on the system clock setting, is a measure of time which is responsible for the tick. Scaling may be pre-scalar or post-scalar. Modes of timers are counter, PWM or pulse generator, etc. Thank you. Now let's see the code we have written for micro oven simulation. So this is the code written for the micro oven simulation in C language with the help of mentors at Emertxe. It is pretty long. We have already built this code. Now let's see whether this code works or not. File. Let's reload last. So these are the four modes in a microwave oven. We will select first mode. It is showing power 900 watt. Let's set the time. For our consistency or our convenient, we will set the time for 5 seconds. Enter. See, we can see if pressed 5, it will pause. See, now time has stopped and fan has also stopped because we have pressed 5. Now we will press 4 to resume. You must have heard the timer or buzzer. Now let's select second mode, which is grill. We will set the time for 15 seconds. Let's press hash enter. If we have to stop in between, we can press the key 6 and stop the microwave oven. Now let's see convection mode and let's see how it works. For convection mode, we have to set the temperature, so we will set the temperature for 230 degrees Celsius. Hash. For this, a preheating will be done for 180 seconds, that is for 3 minutes. Let be back before 10 seconds. So we can see that 14 seconds are remaining for the preheating in a convection mode. Let's wait for another 10 seconds. When the preheating will be done, we will enter the time for cooking the food. So 2, 1, and our preheating is done. Now we will set the time for 3 seconds. So our food is being cooked. In the start mode, the microwave oven has been automatically set for 30 seconds. Let's see. See, we can increment for another 30 seconds by pressing 4. See, it is incremented by 30 seconds. We can see 54 seconds. Let's stop it. So now we can see that all the four modes are working very nicely. And finally, I would like to thank Emertxe for giving me this opportunity for the internship. And thank you.